All right, so in this topic, we are going to talk about the other two trig functions. Now, again, yesterday we talked about tangent, and the tangent function, according to the reference angle, is tan theta, reference angle is equal to the opposite divided by the adjacent. Well, with the other two trig functions, we are going to start talking about what do we do with the hypotenuse, because I know it's tangent, it only dealt with the legs. So the first ratio is going to be the sine ratio. With the sine ratio, it's the ratio of the opposite leg to the hypotenuse. So when you are looking at reference angle A in this case, to take the sine of A, it is the opposite. In this case, it would be CB. We're going to divide that by the hypotenuse, which is AB. Again, if I would like to find out who sine of B is, that ratio is opposite of B, leg is AC, and divide that by the hypotenuse, which again is AB. So that's how you would find the sine ratio. It's always opposite divided by hypotenuse. Now, for the cosine, we are now going to take the ratio of the adjacent leg, and we're going to divide that by the hypotenuse. So to find the cosine of A, we're going to take the adjacent leg, so that's the one it's touching. In that case, it would be AC. We're going to divide that by the hypotenuse, again, is AB. And now to find the cosine of B, we're going to take the adjacent leg, which in this case is CB, the one touching it, divide that by the hypotenuse, which is AB. So those are the ratios that we're going to be using for the sine, cosine, and the tangent ratio. If you ever forget, think of this acronym. You want to take a dip in the pool? You got to SOHCAHTOA. So remember, SOHCAHTOA. Sine is equal to OH. O divided by H, opposite divided by the hypotenuse. Ca is cosine ratio, so cosine is equal to the adjacent divided by the hypotenuse, and TOA stands for tangent. Tan is always equal to the opposite leg divided by the adjacent leg. So again, you want to take a dip in the pool, you got to SOHCAHTOA. So we're going to take a break from that for a second. I'm going to talk about angle of elevation and angle of depression. Now, with angle of elevation, let's suppose you are looking straight forward, so this would be your line of sight. And let's say you look up at a bird or the clouds in the sky, and that angle, when you look up from your line of sight, right here, is the angle of elevation. So again, when you're looking up at an object, you make this angle here, line of sight, and whatever you're looking at above. Now what happens is you end up forming a right triangle here with that angle of elevation. So likewise, the angle of depression, this time you will be looking down at an object. So let's suppose you are I don't know, in a building or a tower, and you are looking down at somebody below, okay? Hey, friend. So you are line of sight, you take your line of sight, and you're looking down at them, okay? And that angle from the line of sight down is the angle of depression. So again, what happens is we end up forming a right angle between the two objects. All right, so now let's go ahead and practice our first trig function and our second trig function, the sine and cosine. So we have triangle UWV. We are going to find the ratios of the sine W and cosine of W. So to find the sine of angle W, we are going to start with angle W and find, again, the opposite divided by the hypotenuse. So opposite leg is equal to 30. The hypotenuse is 34. And then from here, you're just going to take the calculator and divide that. But since we're going to write this as a fraction and a decimal, we're going to go and reduce this down by 15 to 17. So 15 divided by 17 gives us 0.8824, rounded to the nearest 4 places. Okay, and now to find the cosine ratio of angle W, cosine angle W, is equal to the adjacent divided by the hypotenuse. So cosine of W, the adjacent leg is 16. We're going to divide that by 34, the hypotenuse, and that's going to give us 8 over 17 as a fraction. However, when I divide 8 and 17, I get 0.4706, rounded again to the nearest 4 digits. All right, so now that we have those two, I'd like you to go ahead and try checkpoint 1 on the back side. So go ahead and pause this video, work it out, and when you are ready to find out what the answers are, hit play. All right, so after you've worked this out, sine of angle B again is the opposite divided by the hypotenuse. So you should have done 21 divided by 29, which is 0.7241. If you were looking for the cosine of B, you are going to take, this time, the adjacent divided by the hypotenuse. So you should have done 20 divided by 29, which comes out to be 0.6897. All right, correct whatever you need to. All right, let's check out example 3, real world problem. You are at the top of a roller coaster 100 feet above the ground. All right, here we are right here. And the angle of depression is 44 degrees. We want to know how far away, how far the ride down is to get to the bottom of the hill, which is what is x. So when you are looking at something like this, you have to keep in mind what you're given. And this is going to form a right angle with a line of sight going down. So what we have, according to the reference angle 44, is the opposite, and we're looking for x, which is considered, well, the hypotenuse. So since we have O and H, well, what we want to do is set this equal to the sine ratio. So we're going to take sine of 44 and set that equal to the given values opposite, which is 100, divide that by h, which is now x. The goal now is to solve for x. So in order to do that, let's go ahead and do our algebra. So x times, I'm going to go ahead and times x on both sides. So that's x times sine 44 equals 100. Divide by both sides by sine 44, divide by sine 44. So x equals whatever 100 divided by sine 44 is. So what you're going to do is take your calculator and hit 100 divided by, hit sine 44, and then hit equals, and what we end up getting is 143.95. So we'll go ahead and round that to 143.96, and so that ride going down is about 144 feet down. All right. Now in example 4. So in example 4, we are going to look for two segments now, x and y. And again, we're given just one segment. We've got a reference angle, and that means we're going to have to use some trig functions in order to find both of these sides. So I'm going to go ahead and figure out what's given to me. So according to the reference angle, x is considered the opposite side, y would be considered the adjacent side, and then obviously we have the hypotenuse left over. So I want to go ahead and find the length of x. Now in order to find length of x, that's going to require the opposite side and the hypotenuse. So therefore, OH tells me I need to use the sine function. So sine 35 is going to equal the opposite, which is x, divide that by the hypotenuse, which is 20. Now from here, I'm going to just solve for x. So once I multiply both sides by 20, 20 times sine 35, that's going to give me x. So let's go ahead and plug this into the calculator. 20 times, hit sine, type in 35, hit equals, and we end up getting 11.47. All right, so there's our x value. Now from here, you have two options, 11.47. You can either use Pythagorean theorem to find y, or you can use another trig function to find that as well. But what I'm going to do, since we're sticking with trig, we're going to go ahead and find y using the adjacent and the hypotenuse ratio, which is going to require the cosine ratio. So cosine 35 will equal adjacent y divided by hypotenuse, which is 20. And let's go ahead and solve for y. So I'm going to multiply 20 by both sides. 20 times cosine 35 will give me y, and that value in the calculator says 20 times cosine 35, type that in, about 16.38 would be our y value. All right, and again, if you do decide to do Pythagorean theorem, knowing that you have two sides, you should get about the same answer. Okay, so last but not least, we do have example 5. Now at example 5, we are given a basketball court, and the goal is to find out what is the horizontal distance given the length of the court, 94 feet, and we also need to find the width of the court. So for the purpose of this, I'm going to go ahead and call the width of the court y. Now, according to the reference angle 62, what I have is 94 feet would be the opposite length. X is going to be the hypotenuse, as you can see across the 90-degree angle, and therefore y is the adjacent side. So I'm going to go ahead and find x first. I'm going to find the distance between the corners of the basketball court. And that's going to require me to use the opposite and the hypotenuse, because I do know the opposite side. So let's use sine. To find the diagonal, we're going to go sine 62 is equal to opposite 94, divide that by hypotenuse, which is x, solve for x. So in order to do this, we're going to go ahead and use our algebra. Times x on both sides, we get x sine 62 equals 94. Divide both sides by sine 62, so now we get 94 divided by sine 62. Type that into the calculator. 94, hit divide, hit sine, hit 62, set that and hit equals, and that is about 106 feet. Let's go 106 point, it says 4.6, we're going to go 106.5 feet for the diagonal of the basketball court. All right, so again, once you know this height, you're more than welcome to use Pythagorean theorem, but again, because we are getting triggy with it, I am going to use a trig function. So in order to find y, which is a, I have two options here. I can either go tangent on this because I have 94 and I want to find y, so opposite over adjacent gives me tangent, or I could use adjacent divided by the hypotenuse, which I do know, 106.5, and I can use cosine. But for the purpose of this, why don't I just use tangent, because I can. So I'm going to go tan on this. Tangent 62 is equal to the opposite, which is 94, divided by the adjacent, which would in this case be y. So solving for y, y times tan 62 will equal 94, just times y on both sides. Divide both sides by tan 62, so 94 divided by tan 62 will give me about 49.98. So I'm going to go ahead and round that up to 50 feet. So about 50 feet for the width of the basketball court. All right, well, those are all of our trig functions set up. So again, you want to remember so, ka, toa. When you want to dip in a pool, just remember you got to soak a toa. Again, so is the sine function. So s sine is equal to opposite divided by hypotenuse. Cosine is the ka. So cosine is equal to the adjacent divided by the hypotenuse, and toa is our tangent. That is equal to the opposite leg divided by the adjacent leg. So there are our three trig functions, and you want to use them dependent on what you're given and what you're looking for. Thank you for listening, and good luck on the homework assignment.